This is a video about Ohm's law, the most important electrical concept. The first aspect of Ohm's law is voltage, which could be your total voltage source, your branch voltage, and it's essentially the potential difference between 2 points. So let's say we have a circuit here with a 10 volt power supply, a resistor and a ground, which is 0. Up the top, you have a potential difference of 10 volts. Down the bottom, where the ground is, a potential of 0 volts. A voltage could come from anywhere. It could be a battery, a power source, or a main supply, in which case it would come out at 240 volts in Australia. It was discovered by Alessandro Volta and is the push or electromotive force behind our next aspect, which is current. Now, current is, the best way to think of it is the flow of electrons. That's it. That's current. It's measured in amperes or amps after the kind lad who discovered it. Next up, we have resistance. Resistance is the opposition to electron flow, usually in the form of resistors in the circuits we use. It could be in parallel or in series. Series are easy to add. You just add them straight as they are, R1 plus R2. In parallel, however, the formula is 1 over R1 plus 1 over R2 inverse is R total. So let's say we have 5 ohms and 8 ohms in parallel. 1 on 5 plus 1 on 8 invert equals 5 plus 8 over 5 times 8 inverted, 40 on 13 inverted, 13 on 40, which equates to approximately 3 ohms. Now V equals IR, that is Ohm's law, that's exactly it. So putting in the formula, let's say we have a current of 1 amp, resistance of 2, V equals IR, 2 times 1, 2 volts. Now, we can apply this if we don't know another aspect. So let's say we don't know current or we don't know resistance, we can rearrange the formula. So in a circuit like this with 6 ohms, 3 ohms, 9 volts, we add our resistances. We've got 6 plus 3, 9 ohms. V equals IR, rearranged, I equals V on R. 9 on 9, 1 amp. Now we can also apply this to a parallel circuit because we know that every node is a place of uniform potential. So in this circuit, let's say this whole area is 10 volts. Applying it to this, we can find the branch current for this resistor with a 5 ohm resistor. I equals V on R, 10 on 5, 2 amps. Or over here, let's say we have a 1 ohm resistor with a drop of 10 volts. We've got I equals 10 on 1, which equals 10 amps. That's the most important electrical concept, V equals IR.